Jai Hind everyone. Today I am going to talk about the signal and system. The topic basically I am going to talk about is signals. Okay, so here I am going to talk about the standard signals. What are the classifications of the signals? What is the definition of signal, and some examples based on these signals. So, as we know that most of the signals are dependent upon the science, and most of the signals, the concept of signals arise in a wide variety of fields of science and technology as communication, circuit design, etc. Right. So, we can define these signal as a function representing a physical quantity which may be a function of one or more variables, more independent variables like function like time, position, distance and temperature, etc. Right. And these signals, they contain information about the behavior of or the nature of some other phenomena. If we talk about the electrical engineering, we have the input or the excitation and the output of the system in terms of voltage and the current, right? So, basically most of the cases these current and voltage are dependent upon the time. So, we can say that for any system these voltage and current can be called as the signal, right? So, there are variety of standard signals, right? So, that is step signal, ramp signal, impulse signal and the parabolic signal. Other standard signals can be the sinusoidal. We have a lots of signals, that sinusoidal signal, the exponential signals, the gate function, all these are covered in the signals. So, I will talk about these signals, standard signals one by one, and then I will give a review about the step signal, about the exponential signal and the gate signal, and what is the sinusoidal signal. Okay. So, the step signal, you can represent it by UT, okay, and graphically it can be represented as a line, horizontal line with amplitude, let's say A, okay, which is parallel to the horizontal axis. Let's say this is T, and I can write the UT will be equals to, with its magnitude A, for t greater than equals to 0, or otherwise it is 0 for less than 0. Mathematically I can write this for step signal, right? If the value, if the signal is, if the step signal is unit step signal, then the value of A will be equals to 1, and it is called as a unit step signal. Similarly, for ramp signal, it is represented by RT. Okay. So, ramp signal is represented by this straight line with this, let's say, slope is K. Okay. Graphically, I can represent the ramp signal like this, and mathematically, I can write the ramp signal RT will be equals to K into T for t greater than equals to 0, and it is 0 for t less than 0, right? If I am talking about the unit ramp signal, then the value of K will be equals to 1, right? And this will be the unit ramp signal. Okay. Now, the impulse signal. Impulse signal is represented by delta T, okay, and I can represent it on a particular point. Let's see, it is A, where A is the area, right? And it is mathematically represented by delta T will be equals to A only at a single point, that is T is equals to 0, and its value is 0 at all other points, right? And the value of area A will be equal to minus infinity to infinity delta T dt equals to 0. Let's see, let me write this. Okay. And the parabolic signal is represented by this parabola. Okay. I will represent it by function ft with respect to time t, and its value is kt square. And in case of impulse signal as well, if I am talking about unit impulse signal, then I can put the value of A as equals to 1, right? And now parabolic signal ft can be represented by kt square for t greater than equals to 0 or 0 for t less than 0, right? If I am talking about unit parabola signal, then the value of k will be equals to 1, and here the k is in case of parabolic signal and the ramp signal is unity, slope, right? If I am talking about the unit parabolic or unit ramp signal, then the value of slope is unity, that is k. Okay, so another signals will be, let me sinusoidal signal. Sinusoidal signal, it can be represented graphically like this. Okay, and the magnitude will be, let's say, Vm. I am representing in ft. So I can write ft mathematically as Vm sin omega t for t greater than equals to 0, otherwise it is 0 for t less than 0. Okay? And another one is the exponential signal. This exponential signal is represented by, let's say, ft is equals to, this is k into e raised to the power minus at, and its value is 0.368 k at tau is equals to 1 by a, where tau is the time constant, right? This is the exponential signal. So ft here is k into e raised to the power minus at for t greater than equals to 0, and its value is as well 0 for t less than equals to 0. So these are the other standard signals which we can use. And let me tell you another signal, that is the gate signal, right? And gate signal is represented, depending upon this gate signal we can define the gate function. Okay, so this gate signal is represented by a rectangle gt with respect to t. It is represented by a rectangular pulse starting from point A and ending at point B with a unity height. So I can write this gate signal between point A and B as ut minus A minus of ut minus B, and the magnitude is, height is 1. Okay, so this is known as the gate function or the gate signal. So depending upon these signals, let us synthesize some waveforms depending upon the gate signal, depending upon the standard signal. So first example is the synthesize the given waveform shown in figure below using the standard signal. So I can solve this waveform depending upon the gate signal. So you can see here there are two different magnitudes in this waveform, +1 or -1. From 0 to A the magnitude is 1, and A to 2A magnitude is -1, and similarly the cycle goes on. So I can write this ft will be equals to, depending upon the gate signal, the magnitude is 1 from 0 to A, and I can write it as ut minus of A. Let me explain you how come I am getting this ut minus of ut minus A. See, this is our ut, right? If I want the signal up to this point A, right, this is my output, है ना, मुझे ये आउटपुट चाहिए, तो what should I do? इस आउटपुट के लिए, just a second, right, this is my output कि मुझे क्या चाहिए, 0 to A तक का सिग्नल चाहिए. तो अगर if I'll subtract this signal from u1t to u2t, right, which is actually t minus A shifted signal, if I subtract the signal, this signal from this signal, then I am getting this value, right? So what I can write for this signal, that this is ut, and the amplitude of each signal is here, 1. Okay, so 1 into ut, right, because the step signal is represented by its magnitude, and this is 1 into ut minus A. The signal is shifted by the amplitude, by the scale A, right? So if I am subtracting from this signal to this signal, then I am getting this value. So I can write this value as magnitude is A and this can be written as UT minus A. ठीक, तो यहाँ से मैंने ये चीज लिखी है. Similarly, इसके लिए भी आप क्या करेंगे, from UT minus A में से if I am subtracting this UT minus 2A, so I am getting this value with the same magnitude, that is minus 1. So I can write it as minus 1 UT minus A minus of UT minus 2A. And similarly, again I am writing for this function 2A to 3A, magnitude is plus 1 and this will be UT minus 2A minus of UT minus 3A. ठीक. Similarly, then minus 1 again, and this is UT minus 3A minus of UT minus 4A. I can write it as UT minus 4A. ठीक. And up to so on. This goes on. Now I can easily simplify the values. This is minus of UT minus A and minus of UT minus A. So simplified version is FT can be written as UT minus this value and minus. So minus of twice of UT minus A minus of this is minus UT minus A and this is plus UT minus. So this get cancelled out, right? Again this is minus of UT minus A and this, so I can write as twice of UT minus 3A. Then UT minus 4A, वहाँ से 4A से शुरू होगा magnitude, again 4A plus का होगा, उधर भी plus का होगा. Okay, just a second. This is minus minus plus. Okay, so then this is minus minus plus and this is also plus, so this will not get cancelled out and I can write it as minus of 2 times plus of 2 times of UT minus 2A. Okay, because this minus sign और यहाँ भी minus का sign है, तो ये plus हो जाएगा और ये भी plus हो जाएगा. तो answer will be UT minus twice of UT minus 2A plus UT minus 2A minus 3 times of U. Again आएगा हमारे पास twice of UT minus 4A and up to minus of twice of UT minus so on, UT minus 5A up to so on. So this will be the output. This will be the answer. Similarly, I can solve this waveform. Now, depending upon the standard signal, that is the step signal or the gate signal, I can synthesize. So I can I can write this FT will be equals to, हम 3 पार्ट्स में डिवाइड करके अपना सॉल्व कर सकते हैं बिकॉज द मैग्नीट्यूड इज डिफरेंट फ्रॉम 1 to 2 एक आप F1 मान लीजिए, F2 to F2 to 3 आप F2 मान लीजिए एंड 3 to 4 अगेन आप F3 मान लीजिए बिकॉज मैग्नीट्यूड इज डिफरेंट. ओके, सो from 1 to 2 magnitude is 1, right? And the signal कहाँ से कहाँ तक है, UT minus 1 minus of UT minus 2. ठीक, then again 2 to 3 this magnitude is twice plus 2 हो गया. सिग्नल F2 कहाँ से 2 से 3 तक है, तो you can write it as UT minus 2 minus of UT minus 3. Now plus third signal which is from 3 to 4 and the magnitude is again plus 1. So I can write it as UT minus 3 minus of UT minus 4. Now you can simplify this given signal. So it will be FT will be equals to UT minus 1 is here. So I can write it minus of UT minus 1 and the magnitude of then plus of UT minus 2. इन दोनों को solve करके आया. ठीक, UT minus 3 उधर भी है हमारे पास, twice minus of twice and plus. So I can write in minus of UT minus 3. ठीक, and ये आ गया हमारे पास minus of UT minus 4 will be the answer. So this is very simple. Now another one is we express the waveform in terms of step and ramp signal. So using this step signal, that is gauge function, or the ramp signal, I am solving this equation. So I will solve from 0 to 1 signal F1 and 0 to 2 signal F2, right? So for ramp function, I can first of all what I have to do is we have to find out the slope. So from 0 to 1 slope will be m is equals to y2 minus y1 upon x2 minus x1, right? So the value will be what is y2? 1 minus 0 and x2 is 1 minus 0, right? So this is y2 1 minus 0 upon 1 minus 0. What I am getting is 1 plus 1. एंड m1, और इसके लिए m2 भी साथ साथ निकाल लेते हैं, फाइंड आउट कर लेते हैं. फॉर दिस, सो यहाँ 1 से 2 गया, then y2 is again 1 minus 0, y1, okay, and this is x2 minus, sorry, x1, so x2 is again 2 minus 1, तो slope is 1 ही आ रहा है. ओके, 2 minus 1, ओके, दोनों केसेस में m1 and m2 both are 1. ठीक है, तो आई फॉर फंक्शन f1t आई कैन राइट व्हाट, द स्लोप into t minus the point at which the slope is cutting the t-axis. In terms of gate signal, I can write it as ut minus 0 minus of ut minus के 1. ठीक, plus for f2 के लिए f2 will be equals to, see, f1 plus f2 will be equals to signal ft. Okay, so f2 will be the slope which is coming out to be 1, t minus the point slope is cutting at point 1, so t minus 1. In terms of gate signal, it is from 1 to 2, so I can write it ut minus 1 minus of ut minus 2. Now I can simplify these two functions by adding, ft will be equals to f1 plus f2, so this will be, okay, 1 into t into ut minus t into ut minus 1, right? And this is again coming out to be plus t minus, sorry, t minus 1 into ut minus 1 plus minus t minus 1 into ut minus 2. So a point that I have missed to tell you is this is ut minus 2. Okay, इसको यहाँ correct कर लेते हैं. So a point what I have missed is कि the relationship between the signals, these step signal and ramp signal and this, ठीक है. So the derivative of ramp signal is your unit signal, step signal I mean, and the derivative of step signal will be equals to your ramp step signal का, sorry, will be equals to your impulse signal. ठीक है, एक पॉइंट ये. सो अपोजिट देखें तो integral of step signal will be equals to the ramp signal and integral of ramp impulse signal will be equal to the step signal. So I can write it as RT will be equals to T into UT. ठीक है, तो ये हम प्रॉपर्टी यहाँ यूज करने वाले हैं, ये हम यहाँ यूज करेंगे इस फॉर्मूले में, ये सॉरी इस एग्जाम्पल में. सो T into UT will be equals to your RT. ठीक, now here what I am having is t into ut minus के 1 है मेरे पास. So I have to, what I have to do is कि मुझे इसको t minus के 1 से अगर मैं मल्टीप्लाई कर दूं, यहाँ पर मैं -1 + 1 ले लूं, तो t minus के 1 into ut minus के 1 will be my ramp signal, right? तो मैं यहाँ पर इसमें चेंज करके t minus 1 + 1 कर दूंगी, and by taking t minus 1 into ut minus 1 I can write as minus of RT minus 1. ठीक, and with this minus sign यहाँ +1 बचा है, तो minus of ut minus 1 मेरे पास यहाँ से बचा. then यहाँ से अगेन क्या बन गया मेरे पास, प्लस ऑफ RT minus 1, ut minus 1. अगेन इस वाले में आई हैव इधर ut minus 2, तो यहाँ पे हम -1 t minus 1 ऑलरेडी है, -1 + 1 और करेंगे, तो t minus 2 के साथ ut minus 2 कंबाइन करके आई कैन राइट RT minus 2, राइट. वहाँ क्या बचा हमारे पास, ओनली +1, बाहर माइनस है, तो आई कैन राइट माइनस ऑफ ut minus 2. मोर सिंप्लीफाई करेंगे अभी हम इसको, तो हमारे पास क्या बच रहा है, ये RT minus 1 से RT minus 1 कैंसिल आउट. ठीक, सो फाइनल आंसर विल बी, now RT final answer will be equals to RT minus of ut minus 1, okay, and minus of RT minus 2 minus of ut minus 2. ठीक है, रैम्प सिग्नल को और इसको प्रॉपर वे में आई कैन एक्सप्लेन. दिस इज द रैम्प सिग्नल, राइट? ओके, सॉरी. if I want the signal till 1 here, so what I have to do is कि ये signal, negative signal, I have to subtract from this RT. I have to subtract this minus of RT minus 1. ठीक है, and then उसके बाद क्या बचेगा, this signal. अगर ये सब delete रब हो subtract हो जाएगा इसमें से, right? तो what is left, this. तो अगर मुझे ये भी नहीं चाहिए, this is the step signal, ये portion, तो ये भी हमें subtract करना पड़ेगा to get this. ठीक, तो मेरे पास यहाँ 1 था, तो if आप देखें RT minus RT में से what I have done is RT में से RT minus 1 मैंने subtract किया, right? And then what is left, this and this. ठीक, and ये भी मुझे नहीं चाहिए because I have another signal here, तो ये भी मैंने subtract किया minus of UT minus 1 because ये signal यहाँ से start होगा, ये इतना बचेगा. So जब when I subtract this signal and this signal from this signal, then I'm getting this value signal, the ramp signal from 0 to 1. So this is the basic funda for solving the ramp signal. Now coming to the classifications of signal. So these signals are classified depending upon whether the signal is depending upon the nature and the property characteristics of the signal, right? So depending upon the nature and characteristics, signals are classified as continuous and discrete time signal, even and odd signal, periodic and non-periodic signal, deterministic and random signal or static and random signal, energy and power signal, and the last one is the causal and non-signal. So talking about these signals one by one, so what is continuous and discrete time signal? So continuous signals are those signals which are continuous in nature, right, with respect to time. You can see this example, these signals are continuous with respect to time. So, and the discrete time which take on discrete values which are defined at particular discrete values are called the discrete signal. You can see this example, these the signal is defined only at 1, at 2, at 3. In between 1 and 2 the signal is not available. So these type of signals are called as the discrete signal, and these continuous time signals are represented by these parentheses with the T inside it, and this discrete signal is represented by NT, this bracket, okay, by T or NT like this. Okay, this is the another difference between the continuous and the discrete time signal. So another signal is the even and odd signal. So even signals are, if signal xt is the even signal, then even signals are those signals which are symmetrical to its time reversed counterpart. That is, if this signal is, this is the signal xt, then its time reverse counterpart will be the mirror image like this, right? Symmetrical. That is, these signals are symmetrical with respect to the vertical axis, right? So these are called the even signal. So even signal can be mathematically represented as xt is equals to x of minus t. And odd signals are anti-symmetrical to its time reverse counterpart. That means if signal xt available in the first quadrant, then its counterpart, reverse counterpart is this symmetrical, and anti-symmetrical is this. ठीक? So this is first quadrant का third term. And mathematically I can write for the odd signal, xt can be written as minus of x of minus t. For example, here example, you can say x square t, right, t square, t ki power 4, all these are the, yeah, cos omega t will be the example for the even signal. For the odd signal, you can write t cube, t ki power 5, and sine omega t. These are the signals for the, these are the even signals, right? And the value of, a signal is composed of these both xt plus x naught t, right? So for xt, if I have to find out the even component of signal, any signal xt, then the value is 1 by 2 xt plus of x of minus t. Tick. And if I have to find out the odd part of any signal, then the value is 1 by 2 x of t minus of x of minus t. ठीक है? So अगर कोई even signal है, then we have to find out the odd component of that signal, and if signal is odd signal, then we have to find out the even component by using these two formulas. Now next signal is periodic and non-periodic signal. Third one is the periodic and non-periodic signal. So the signals which are I have drawn the waveform. Where is that? Okay, signals which are continuous with respect to time, which are signals which are periodic signals are those which are repeated after a particular interval, right? They have certain, like this. This is the signal 0 to 2, then it is repeating from 4 to 6, then it is then 8 to 10. So you can see here that this signal is repeated up to so on. So this type of signal is called as the periodic signal, which is repeating after a particular interval of time. So you can see here, and the time period will be, I can write it, xt will be equals to xt plus capital T. So you can see here that this signal is repeating after the cycle after 4, t is equals to 4. 0 to 2 I have the output, and 2 to 4 no output, but the cycle is repeated after 2. 4 to 6 again I am having output, 6 to 8 nahi hai. So time period for this cycle is, this signal is 4. So period, and those signals which are not repeating, right, which are like this. Same signal ka example lete hain. This is 2, 3, then 5, 4, 6, let's say 7, let's say 8. So you can see कि ये सिग्नल आपको दिख तो रहा है कि रिपीट हो रहा है, बट द टाइम पीरियड इज नॉट मैचिंग. ये 0 to 2 मिल रहा है, यहाँ 3 to 5 मिल रहा है, बट यहाँ 7 to 8 मिल रहा है. देन 2 to 3 में 0 आउटपुट है, देन 5 to 7 है. तो टाइम पीरियड इसका, दिस सिग्नल इज नॉट पीरियोडिक बिकॉज इट इज नॉट हैविंग अ पर्टिकुलर साइकिल. एक प्रॉपर टाइम पीरियड के बाद रिपीट नहीं हो रहा है. सो दीज टाइप ऑफ सिग्नल्स आर कॉल्ड नॉन पीरियोडिक. ठीक है. नाउ द अनदर वन इज causal and non causal signal. ठीक है. Signals that do not exist before t is equals to 0 are called the causal signal, right? And those who exist after t is equals to 0 are called the non causal signals, right? And another one we are having the energy and power signal. ठीक, energy and power signals are basically the finite in nature, and energy can be defined as, if I am talking in terms of integration, then signal xt ka whole square of dt will be the energy signal, and power signal will be 1 upon time upon of the, or you can say agar limit iski put kare for t tends to infinity, right? So the value will be from minus t to t and xt square dt. ठीक है. And power signal will be 1 by t integration from, let's say, minus infinity to infinity, and this is xt ka whole square into dt will be the power. So the signal which is an energy signal must have average power will be equals to 0, and the signal which is a power signal, those signals are having the energy as infinite, right? The energy of those signals which are having which are called as the power signal, their energy is infinite, right? So these are time limited signals, these energy signals, and these are not time limited signals. Okay. So depending upon the energy and power signal, we have to find out the energy and the power of these signals and determine whether the signals are energy signal or a power signal. So let's simply nothing is to be done here. Only we have to put the formula. So let me first find out the energy of this signal if it is having. So the value will be, because of this infinity, since the formula for the energy signal is minus infinity to infinity xt mod of xt square into dt. But because of this ut, the limit will goes to 0 to infinity, and the function xt here is k into e raised to power minus u et. and dt, right? Now sorry, इसका whole square, ठीक? तो k square into when I am integrating this term e raised to power minus at का whole square ही रहेगा upon will be equals to minus 2a, ठीक? And infinite limit will be 0 to infinity, ठीक? And the value will be then k square and e raised to power infinity minus infinity is 0, minus 2a भी हम ऊपर नीचे ले लेते हैं, e raised to power minus infinity is 0 and this will be 1. So the value of here is k upon 2a, ठीक है? 2a कैसे है? Okay, this is k square, k into minus 80 का, ठीक है? तो this will be the energy signal. Since it is an energy signal, so it must have the average power which will be equals to 0. And similarly, so this signal is energy signal. Now for say another one, let me find out the energy again. Minus infinity to infinity xt का square. Again here, due to this ut, the limit will change to 0 to infinity, right? And xt is simple k square into dt. So the integration will be k square into t, and 0 to infinity where we have to put the values and it comes out to be infinity, right? So this signal is a power signal, right? And this is a, because the energy is infinite here, and this is energy signal because energy has having some finite value here. So I can directly write the average power of this signal is 0. And since in this I am getting an infinite energy, so this must be a power signal. So I have to calculate the power of the signal, which will be equals to 1 upon t, right? And again 0 to 1 upon t, and this will be 0 to infinity k square into dt, okay? So it is 1 upon t, and the value is k square is a constant, and what I am getting here is again the t, okay? So the for power signal, sorry, this is not the formula for power signal, मुझे यहाँ correction करना होगा. Since it is an energy signal, तो power का क्या होगा? power के लिए for power I have to calculate 1 upon 2t, okay? Limit t tends to infinity, ठीक? And the value will be from 0 to t k square, right, into dt. So ये आएगा हमारा 1 upon 2t, and this will be k square is constant, t small t from 0 to t, ठीक? For t tends to infinity, right? तो इस केस में p will be equals to k square upon 2t, and the value will be 0 minus 0, so t get cancel out, and the value of the power signal will be equals to k square by 2. So in this way I can find out the value of the energy signal and the power signal. Now another example is based on the periodic and non-periodic signal. So we have to find out the fundamental period of the signal if it is periodic in nature. अगर periodic है ही नहीं तो we have to, तो फिर fundamental period भी नहीं होगा. So for first signal, obviously I know that sin t and the cos t both are periodic in nature, and since we know omega is equals to, time period will be equals to, for this signal xt will be the time period for sin t plus cos t, ठीक? So this, for this omega is equals to 1 here, and यहाँ भी omega is equals to 1 है, omega 2, right? So t1 will be equals to we know that omega will be equals to 2 pi by t1. So t1 will come out to be 2 pi by 1 here, and similarly यहाँ से omega 2 again 2 pi by t2, and t2 will be again here 2 pi by 1, that means 2 pi by. And for period, to check whether the signal is periodic in nature or not, period, to find out the period of the signal, the ratio of t1 by t2 must be a rational number if signal is periodic, right? So अगर हम put करें t1 by t2, so it is coming out to be 1, right? So this signal is periodic in nature with the time period equals to t1 is equals to t2 is equals to 1. ठीक है? And for another example, again for xt, 2 cos 10t plus 1 minus sin 4t minus 1. So यहाँ से omega 1 will be equals to 10 and omega 2 is 4. ठीक? तो t1 will be equals to 2 pi by 10. Okay? So that means pi by 5. And t2 will be equals to 2 pi by 4. That means pi by 2. So t2 by, sorry, this will be t2 by t1. Okay? तो यहाँ तो सेम था इसलिए करेक्शन है नहीं है. This will be pi by 2 upon pi by 5, which is coming out to be pi से pi cancel हो गया as a 5 by 2, right? So which is a rational number, right? So so the time period for the above signal, which is a rational number, so the signal is periodic. ठीक? So time period t will be equals to twice of t2 or 5 times of t1. So actually the time period twice of t2 अगर हम लिखें will be 1 pi. So the time period for this signal will be pi. Okay, so I hope the questions are clear to you. That's all for today's lecture. Thank you.